Everyone, I am going to explain how to study peripheral smear. But before we should know how to make an ideal peripheral smear. So ideal peripheral smear must have three parts: head, body, and tail. Must at least 3 centimeter long, properly labeled, or fixed before staining. So you can use any staining, either Leishman staining, field staining, Giemsa staining. Okay. So this is the ideal peripheral smear. Ideal peripheral smear is somehow tongue shape smear. Must have head, body, and tail. Okay. So the area of morphology is the zone of morphology, that is the around tail area, just a few millimeter away from the tail area, where the RBC is not touching each other. Normal RBC is the biconcave appearance, and the uniformly stained RBCs. Remember one thing: you should not look at the area where the RBC are overlapping. Always choose the area where the RBCs are not touch borders of RBCs not touching each other. So the fixation, the ideal is Leishman staining or Giemsa staining. So it is a polychromatic stain. It's give a different color to hemoglobin and cytoplasm. So we not need the fixative for Leishman stain, because it already contain a fixative, that is the methanol that fix the slides. It containing two components. First one is methylene blue and second one is the eosin. Methylene blue staining RNA and DNA and give a blue color to the nucleus. Then second one is the eosin that stain hemoglobin and the granules, which give the red color. And the pH of that buffer is very important for Leishman stain. So it must be around 6.8 to 7. Okay. Now, what are the points for peripheral blood smear? We are evaluate the peripheral smear on 4 heading. First, RBC. Second one is white blood cells. Third one is platelet, and final is parasites. In the red blood cells, we have to look for size of RBC, shape of RBC, color, arrangement, inclusion, or any abnormal young RBC, that is the nucleated RBC. In the WBC, we have to look for total count, differential count, then abnormal white blood cells. In the platelet, count and abnormality, and finally any parasites present in the blood. And generally we can detect malarial parasite, Filaria, trypanosoma in the peripheral blood. Okay, let's start with the RBC morphology. First, we have to look for the size of RBC, where it is microcytic or normocytic. If it is smaller than normal RBC value, it is called microcytic. If it is larger in the size, it is called macrocytes. If it is normal in size, it is called normocytic. So what is the criteria? What is the criteria for comparison of RBC size? So we know the RBC size is, that is 7 to 8 micron. 7 to 8 micron in size. So we also know that the smaller lymphocyte, that is one blue dot you can see here, that is nothing but the lymphocytes, smaller lymphocyte. Here you can see a neutrophils. So smaller lymphocyte is also size up to the 7 to 8 micron. So we have to look the area where we can compare the size of the RBC with that of the smaller lymphocytes. So smaller lymphocyte is somehow one single nucleated cells with the basophilic nuclei. Okay, so if it is you can compare the size of the smaller lymphocytes with that size of the RBC. If it is larger than the smaller lymphocyte, it is called macrocytes. If it is smaller than that size, it is microcyte. If it is equal to size of that lymphocyte, we can call the RBC is the normocytic. Here you can RBCs is just similar to that smaller lymphocyte, so we can call it is a normocytic RBC. This is a second example. You can see one smaller lymphocytes here, neutrophil and neutrophil. Okay, this one is the larger lymphocytes. So you can compare, remember one thing, always compare the size of the RBC with the smaller lymphocyte, not the largest lymphocyte. Larger lymphocyte having some of more cytoplasm as compared to smaller lymphocytes. So RBC is just equal to the size of normal lymphocytes, so we can call it is a normocytic normocytic RBCs. So here's again example of smaller lymphocytes, and that one is the larger lymphocytes. Okay. Magnification, you can see two smaller lymphocytes and one neutrophil. You can easily compare the size of the RBC with that smaller lymphocytes. The RBC, you can easily appreciate that the RBC is just equal to the size of that lymphocytes. So you can call it is a normocytic, normochromic. Second one is how to detect the chromia. The central normal RBC central 1/3 is the pallor. So this is pallor is formed by the chromia. Suppose this is the RBC. So central, you can see central 1/3 blank space, that is the pallor, nothing but the pallor. If it is expanded more than central 1/3 area, you can call the hypochromic RBC. You can get hypochromic RBC only in the case of anemia, where the hemoglobin concentration is reduced. So now come to the next point, that is the microcytic hypochromic anemia. You can see these two lymphocytes. Now compare the RBC. The RBC is just smaller than that particular lymphocytes, and you can also appreciate the chromia in the RBC. You can only see this only ring of RBCs remain. The central 1/3 pallor, that is the central 1/3 white space, is expanded, and you can only see a ring of hemoglobin. So that is the here you will get the decrease in size of RBC, that is the microcytic, and decrease the chromia. The central 1/3 portion is expanded, that is the hypochromia. So that is the ideal picture of microcytic hypochromic anemia. You always get the microcytic hypochromic anemia in iron deficiency anemia. Second one is thalassemia. Third one is the sideroblastic anemia, and fourth one is the anemia of chronic disease, sometime in the anemia of chronic diseases. Now that is the microcytic anemia. Okay, here you can see the larger RBC. Okay, now compare this RBC with this RBC. You can easily appreciate there is something wrong with the size of RBC. Here you will get some larger RBC in the picture, and one hyper segmented neutrophil. Remember one thing, neutrophil must contain neutrophil having 3 to 5 lobes. Now you can easily appreciate many lobes, 1 2 3 4 5 6 and 7 lobe. So this is the hypersegmented neutrophil, which is the common characteristic feature of megaloblastic anemia. Okay, increase in the size, increase in the lobe of neutrophil. Why you will get a hypersegmented neutrophil? Because these are over maturated neutrophils. Okay, so there is a maturation defect in megaloblastic anemia. That's why you will get the picture like hypersegmented neutrophil, Howell-Jolly body, basophilic stippling frequently in the megaloblastic anemia, increase in the size. So this is the pictures of megaloblastic anemia or macrocytic hypochromic RBCs. So macrocytic RBC, the condition in which you will get the increase in the size of the red blood cells is generally megaloblastic anemia, either due to folic acid or vitamin B12 deficiency. Second one is the anemia due to liver disorders. Third one is the anemia due to thyroid disorders generally, and finally is the lead poisoning. So this is the perfect example of basophilic stippling. Here you will get, here you can see one small RBC with multiple dots, multiple basophilic dots. That is the basophilic stippling. That is nothing but the remnant of RNA. Okay, generally during maturation this remnant are clear from the RBC, but if the maturation is over maturation, there is a defect in maturation, So you will get easily picture of basophilic stippling in the RBCs. You can also see the teardrop cells in the picture. So this is the Cabot ring. So the ring is circled to the RBCs. Okay, it is like this, whole circling the RBCs. This is the features of maturation defect. You can easily appreciate this. You can easily get this in the picture if you get maturation defect in the RBC. So this is the another nice example of Cabot ring. Okay, now move toward the some other abnormal size of RBC. Remember one thing, if you see the difference in the size of RBC, you can call it is an anisocytosis. Aniso means change in the size. If you will get the change in the shape of the RBC, you can call it as anisopoikilocytosis. Poikilo means change in the shape of the RBC. You will get the abnormal shape RBC in the peripheral smear. So this is the best example of abnormal RBC. You can see here the example of target cells, teardrop cells. We can call it as a target cells because it's look like the sign of target sign. Okay, then teardrop cells, it's look like a size shape of the tear, normal human tear, so we can call it as a teardrop cells. So you can get the target cells in mostly in the thalassaemic patient, in liver disorders, any marrow pathology. And second one is the teardrop cells. You will get teardrop cells in myelofibrosis, generally in myelofibrosis and also in MDS. So here the another example of many target cells in one single field. Okay, if you'll get target cells, you must suspect, if you get target cells in the children, you must suspect the thalassaemic disorders. Second one is the liver disorders. The example of an RBC, that is the nucleated RBC. Okay, so generally our RBC is non-nucleated. The nucleus is removed by the maturation process, but sometime you will get the nucleated RBC in the peripheral circulation because our body our body in the crisis stage where we need the RBC very urgently. So the nucleated RBC also come into the circulation. That is nothing but the NRBC. The main important feature you will come to know that is something wrong in the patient's body. So the nucleated RBCs directly come to the circulation without removing of the nucleus. So NRBC is generally present in the neonates. You will get frequently NRBC in the neonatal peripheral blood. But if you will get the NRBC in adult blood, there must be some hemolytical anemia or some crisis, just like a thalassemia and the sickle cell anemia, where you will get easily NRBC. So don't get confused the NRBC with the lymphocytes. So NRBC is just like a central basophilic nucleus with the surrounding cytoplasm, and the lymphocyte is just like a single cells with basophilic cytoplasm. Okay, so importance of NRBC is it's falsely elevated the TLC on the cell counter. So always if you will get the NRBC in the peripheral circulation, you must correct the TLC, that is the total leukocyte count of the patient by the counter. So there is a formula to reduce the NRBC from the TLC. Now next is the sickle cell. This is the example of sickle cell. Okay, so the main confusing factor is the pencil shaped cells in the iron deficiency anemia. And second one is the sickle cell. So how to differentiate the pencil cells from the sickle cells? Just look at the border of the sickle cells. The border is always tapering, so there is the very narrowing of the border, and look at the border of the pencil cells. So next is the example of cystiocytes, that is the helmet shaped RBC. You will get cystiocytes in the DIC condition, in the condition like DIC, like disseminated intravascular coagulopathy, where the blood is consumed, the blood factor is consumed internally, and there is a continuous bleeding in your body. and the certain leukemic conditions like AML M3, acute promyelocytic leukemia. So cystiocytes is the indicator of internal hemolysis. Next is the polychromatic RBC. You can see the color of RBC, that is the basophilic tinge without non-nucleation. That is the earliest stage of maturated RBC. So this is the mature RBC and that is the immature RBC. So always look for polychromated RBC in the peripheral circulation. Now look at the second point is white blood cells, that is how to identify white blood cells in our body. This is the animated picture where you can divide the white blood cells into two categories. First one is the granulated, second was the agranulated. So granulation, the WBC which take the granules take blue color, we can call it is a basophilic. The white blood cells which can take the red color, we can call it is red or orange color, we can call it is the eosinophilic, and the which is neutral in color, we can call it the neutrophils. That is the neutrophils which is having 3 lobes, 3 to 5 lobes. So this is the lobes of neutrophils. Basophil is having the basophilic, that is blue color granules. Eosinophil is the bilobe and having the multiple reddish or orange color granules. Now the second one is the agranulocytes. That is the monocytes and the lymphocytes. Monocytes is the having kidney shaped nucleus or irregular nucleus with not having any granules in the cytoplasm. Second one is lymphocytes. There is a 2 lymphocytes, smaller lymphocytes and larger lymphocytes. So lymphocyte is having central basophilic blue color nucleus with no granules in the cytoplasm. Now next move to the one by one. First one is the neutrophil. Here you can easily appreciate one neutrophil with the multiple at least 3 to 4 lobes. Generally up to the 5 lobes is common. If we will get more than 5 fields, you can suspect it might be a case of megaloblastic anemia. Okay, so that is the neutrophils having 2 to 3 lobes. Here the another example of neutrophils. Now next is the monocytes. Look at the nucleus, a granular cytoplasm. The nucleus is kidney shaped nucleus or irregular nucleus. The size of the monocytes is bigger, is the largest cells, about 17 to 18 micron. Now compare with the size of RBC, that is the 7 to 8 micron. So it is sometime almost double to the size of the normal RBC. So this is the another picture of monocyte. So this is also the monocytic picture, bilobe nucleus with a granular cytoplasm, and the cytoplasm does not contain any granules. Another example of monocytes. Okay, now this is the example of basophil. You can appreciate the basophilic, that is the blue color granules, blue color granules in the cytoplasm. You cannot see the nucleus of the basophils because it is obscured by the granules, that is the basophilic granules. This is the lymphocytes. This is the eosinophil, that is the bilobe, first lobe, and that is the second lobe, and the various orange color or red color granules in the cytoplasm. That's why it is highly bind to the eosin. That's why it is called eosinophils, because the red color granules. This is the another example of eosinophil, that a bilobe nucleus, spectacles nucleus with the red or granular. So the next step is how to calculate TLC, that is the total leukocyte count on the peripheral smear. Okay, how to report the TLC, whether it is increase or decrease in number. So normal TLC count is 4,000 to 11,000. Okay, so average field you can count is 10 average field. You can make an average of white blood cells in the 10 field. If it is suppose, and there is a 4 object in the microscope, 10x, 40x and 100x. you can count white blood cells on 40x, either in 40x or in 100x. So you can make an average of 10 field. For example, if it is average is 2, so in the 40x, okay, so you can multiply the, so averages of WBC is 2, so you can multiply by the 2, so there is a 4, that is the 4000 WBC in the peripheral smear. If the average is 5, you can multiply by the 2, that is multiplying factor average field by the 2, that is the 10,000. So there is a 10,000 white blood cells in the peripheral smear. On the other hand, on the 100x, the multiplying factor is increased because the field is decreased. So the multiplying factor in the 100x is 4, and average WBC must be multiplied by the 4. For example, if you will get 10 WBC in average, the average of 10 field is 10 WBC, so multiply by the 4, that is the 40,000 white blood cells in the peripheral smear. For the platelet, you must calculate the platelet in the oil field. You can't calculate the platelet on the 40x, okay. So the multiplying factor for the platelet is 15. So normal value is platelet is 1.5 lakhs to 4.5 lakhs, okay. So multiplying factor is 15. You must calculate the 10 average field. If, for example, if you will get 10 platelets in each field, so average is 10, so you can calculate that average with 15, that is the 1,15,000. So that is the minimum count of platelet. That is very simple. You can calculate average 10 field. You must have 15 platelet in each field for called is adequate, or a single large clump of platelet is also a criteria for adequacy of platelet. So what is platelets look like on peripheral smear? Here you can see very multiple tiny small dots. This is nothing but the platelets, okay. So these dots are derived from the megakaryocytes in bone marrow. This is a fragmented particles of megakaryocytes, okay. So this is the example of one oil field. Here you can see many platelets, almost approximate more than 15. So we can say this person is having adequate platelet on peripheral smear. So now next come to the parasites. Which parasite you will get if you will get easily on the peripheral smear? First is the malarial parasites. So the main species is Plasmodium falciparum, vivax, malaria, and oval. You will get ring form, schizoids or gametocytes of falciparum or vivax. So the gametes of falciparum is more frequently present, or ring and schizoids are rarely seen on the peripheral smear. On the other hand, in the vivax, you will get the ring form and schizoids of vivax, and very rarely gametocytes of P vivax. So this is the perfect example of banana shaped gametes of falciparum. So there is a central brown particle of hemozoin and totally banana shaped gametes of Plasmodium falciparum. This is another example of a ring form of vivax. So that is the central joining point, and that is complete form ring in the center of RBC. This is nothing but the ring of vivax. Another example, another parasite is the filarial parasites, okay. Don't confuse the filarial parasites with the artifact which is generally present on the peripheral circulation. Remember one thing, the filarial body is always segmented. Here you can easily appreciate the very segmented body of filaria.